In this video, I want to briefly explain how we deal with a lot of combined uncertainties. So when we've got really complex terms of measurements and each measurement has an uncertainty, how we are going to deal with it. So let's assume we have 5 different measurements of things, 5 different independent variables that we measure, and each one of them has an uncertainty. So we've got from A, B, C, D, E, and each one of them has their individual uncertainty. And let's say we want to find out what the measurement and the uncertainty is if we have, for example, something like, let's call our measurement x equals a plus b plus c divided by d times e. And of course we can do that quite easily in terms of our measurement. So that would be actually here what we get for the measurement. But now we also want to know what is the standard uncertainty for this measurement. And let's call that UCC, the combined uncertainty for our measurement. So how are we going to deal with that? So we recognize that in fact what we are doing is we are looking at a division. So we have in the numerator we have a sum, and in the denominator we have a multiplication. So we can treat this as really a division of a sum divided by a multiplication. And if we break it down like that, then it becomes far less daunting. So how do we calculate the uncertainties for the numerator? We have seen that if we want to combine uncertainties for a sum, so then we would use a sort of uncertainty of a sum equals the square root of the uncertainty of one partner squared plus the second one squared. But what are we doing with 3 terms here? Well, we just add the third one as well, u3 squared. So that would be the uncertainty. How do we need to think about it? I said when we are dealing with 2 items, and it doesn't matter whether it's plus or minus, we can see our first one as going in that direction. The second uncertainty goes in that direction. And in order to get the sum of the u1 and u2, we said we just simply do the Pythagoras of that. Now, in this case, when we have a third one, we would do a sort of almost a 3-dimensional Pythagoras, where the third one goes into beyond the plane of the writing, and we would do a 3-dimensional, and that is just simply given by this expression here. And what we also recognize is that for the u1, u2, u3, if we've got a sum or a difference, we always take the absolute. And I indicate that with an A. We take the absolute uncertainties. And of course we get an absolute uncertainty. And it looks like USA, but it's the sum of the absolute uncertainties. Okay, good. So what do we do with the D times E? Well, we can combine the uncertainties for DE. And what we need to do is we can say, right, we know how we deal with a multiplication. Again, we take the uncertainty, this time for D, so that's U4 squared plus U5 squared. And again, it's this plus here, but we don't take the absolute uncertainty. We must take, when we work with multiplication and division, we must take the relative uncertainties. So we have the squares of the relative uncertainties, and we know how we get the relative uncertainty. So we could get U4R. We get this by U4 divided by D times 100. And U5, we would get it in a similar way. So we get the relative uncertainty for the multiplication here in the denominator. So we now can calculate our ultimate goal, that's the division. We can do the combined for the sum. So we would use the our combined one, and that is the square root of the US, the sum, where we have the absolute here, that's this one here, but actually we can't use the absolute. We need to calculate the relative of the sum, square it, plus, well, here we've got this one here, and here we've got the relative already, UDE, relative and squared. So how do we get the USR? So we would take our USA, that's the absolute one, and we divide it by the sum of A plus B plus C and multiply it by 100. So that would be our USR. So that would be the combined uncertainty, and of course we get it as a relative uncertainty, but we can easily then convert that, the relative uncertainty, into an absolute uncertainty if we really want. So it's quite a laborious process, but actually this is the correct process when we are dealing with really complex things. It doesn't matter how many items we have in a sum. It would be actually exactly the same if we had a minus here, for example. It would not matter. Or if we had a division here, it would also not matter, because our combined uncertainty would be really this item here, this UCR, the relative combined uncertainties.